Hello everyone, in this video we'll discuss about stack data structure. A stack is a linear data structure that follow last in first out principle. Stack has one end. It contain only one pointer, that is a top pointer, that pointing to the topmost element of the stack. Whenever an element is added in the stack, it is added on the top of the stack and the element can be deleted only from the top of the stack. In other words, we can say a stack can be defined as a container in which insertion and deletion can be done only from the one end. That is known as top of the stack. A stack is a linear data structure in which items may be added or removed only at one end. This is a real life examples of stack. A stack of dishes, a stack of pennies, a stack of folded towels. Observe that an item may be added or removed only from the top of any of the stack. This means in particular that the last item to be added to a stack is the first item to be removed. Accordingly, stacks are also called last in first out list. It is a simple data structure that allows adding and removing element in a particular order. Every time an element is added, it goes on the top of the stack. And the only element that can be removed is the element that is at the top of the stack. In stack data structure, only one end is there, that is the top of the stack. Insertion as well as deletion can take place at only one end. There are some features of stack. A stack is the ordered list of similar data type. In stack, we can store similar type of data. And stack is the last in first out structure. There are two basic operations that we can perform on stack: push operation and pop operation. Push operation is used to insert new element into the stack and pop operation is used to remove an element from the stack. Both insertion and removal are allowed at only one end of the stack, that is called top of the stack. A stack is said to be overflow state when it is completely full and is said to be underflow state if it is completely empty. For example, we have a stack and in this stack there are three elements. Now if we want to insert element in this stack, but stack is already full, then this type of stack is said to be in overflow state. Now if we want to remove element from this stack, but this stack is already empty, we can say this stack is in underflow state. Next is array representation of stack. Stack can be represented as a linear array. Linear array is a one-dimensional array. Every stack has a variable called top associated with it, which is used to store the address of the topmost element of the stack. It is a position where the element will be added or deleted from. There is another variable called max, which is used to store the maximum number of elements that this stack can hold. Now in this case, the value of max is 9. If top is equal to null, that means stack is empty. And if top is equal to max minus 1, then stack is already full. In this case, the value of top is 4. So insertion and deletion will be done at this position. In this stack, we can store 5 more elements. If you want to insert element into a stack, then top is equal to top plus 1. If you want to remove an element from this stack, then top is equal to top minus 1. Then operations on a stack. There are three basic operations that can be performed on a stack. The push operation, add an element to the top of the stack, and the pop operation, remove the element from the top of the stack, and the peek operation, return the value of the topmost element of the stack. Then push operation. The push operation is used to insert an element into a stack. The new element is added at the topmost position of the stack. Now in this case, top is equal to 4. Before inserting the value, we must first check if top is equal to max minus 1, because if that is the case, then the stack is full and no more insertion can be done. Now to insert element with value 6, we first check if top is equal to max minus 1. If this condition is evaluated to be false, then we increment the value of top by 1. Top is equal to top plus 1. Top is 4, 4 plus 1, 5. Now we can insert element at index 5. Let's see the algorithm to insert an element into a stack. A stack having 4 elements. 3 is the top of the stack and 5 is the value of max stack. First step of this algorithm is if top is equal to max stack. In this case, value of top is 3. 3 is equal to max stack. Value of max stack is 5. Condition is evaluated to be false. Then increase the value of top by 1. Top is equal to top plus 1. The value of top is 3. 3 plus 1, 4. Now we can insert element into a stack at index 4. Now 4 is the top of the stack. Then third step, stack of top is equal to item. We can insert item at top position. Stack of 4 is equal to item. Suppose item is 18. Then exit. This is a complete algorithm to insert an element into a stack. Then pop operation. The pop operation is used to delete the topmost element from the stack. Before deleting the value, we must check if top is equal to null. Because if that is the case, then it means the stack is empty and no more deletion can be done. Now in this case, stack is empty. Then we cannot delete element from the stack. If an attempt is made to delete a value from a stack that is already empty, an underflow message is to be printed onto the screen. To delete the topmost element, we first check if top is equal to null. If this condition is evaluated to be false, then decrease the value of top by 1. Top is equal to top minus 1. Top is 4, 4 minus 1, 3. This is the algorithm to delete an element from a stack. Now this is a stack having 4 elements. The first step of algorithm is if top is equal to null. If top is equal to null means there is no element in a stack. If this condition is evaluated to be true, then write underflow and exit. Otherwise, item is equal to stack of top. Item is 19. 19 is at the top of the stack. Three is the top of the stack. Then decrease the value of top by 1. Top is equal to top minus 1. Top is 3. 3 minus 1, 2. After deletion, top become 2. This is a complete algorithm to delete an element from a stack. Then peek operation. Peek is an operation that returns the value of the topmost element of the stack without deleting it from the stack. This is the algorithm for a peek operation. The peek operation first checks if stack is empty, that is top is equal to null. Then an appropriate message is printed, that is stack is empty. Otherwise, go to step 2. Return stack of top. 4 is the top of the stack. Stack of top is 5. Here peek operation will return 5 as it is the value of the topmost element of the stack. Topmost element is stored at index 4. In next video, we'll learn link representation of a stack.